Hey guys, what's up? Topic of this video is selection of data and graph. Here in this video, we will see how to select the type of data and how to select which type of graph we will use to represent a data. So let's get started. Here we have our first question. Here we have to write the examples of ungrouped and grouped data. Okay, ungrouped and grouped data. So we know that what is ungrouped data. Ungrouped data is the data which have discrete numbers, or we can say discrete data. It means that here if we have 0, 1, 2, 3, 4, okay, so actually you can see they are distinct numbers, so it is a discrete, or we can say ungrouped data. Now here we have our question. Here, write the examples of ungrouped and grouped data. Okay, so let's see. Here we have ungrouped data, okay, and here we have grouped data. Okay, so let's see the examples of ungrouped data first. Here if I write here, actually here we need distinct numbers. Okay, here we need distinct numbers. So if I write here number of persons who liked Pepsi. Okay, here we have number of persons who liked Pepsi. So here you can see here we have number of peoples. Actually it means that here if we draw a graph of it, let's say if we have drawn a bar graph of it, okay, so we will get a distinct number. Okay, we will get a discrete frequency. We can say here we can say that 12 persons are those who like Pepsi, or we can say 20 persons, 14 persons are those who like Pepsi. So here we will get a distinct number. Okay, here we will get a distinct number of it. So we can say that this is an example of ungrouped data. Okay, because here we have frequency, not in grouping. Okay, here we have a distinct frequencies. Clear? Now let's write another example. We can say number of pencils per student. Number of pencils per student. Okay, so here we will get a frequency, a distinct frequency, that we can say 5 persons have we can say 2 pencils, 3 persons have 4 pencils, 2 persons have 1 pencil. Okay, 2 persons have 1 pencil, etc. So here we can get a discrete data, a discrete frequency of it. Okay, so actually here let me write number of pencils among 5 students. Okay, let me write it like that. Okay, it is more clear to you. Here number of pencils among 5 persons, So how can I draw a graph? I can say that here first student have how much pencils? 4. So I will mark like this. Okay, here this bar is representing our first student. So here it has 4 pencils. Okay, here it has 3 pencils, here it has 7 pencils. Okay, clear? So this is another type of ungrouped data we have, an example of we have. Okay, now here we have a grouped data. Okay, so let's see what is a grouped data. It means that here we have things in the form of grouping. Okay, so first of all I can write here the height of persons. Okay, the height of persons. And why I'm writing here height of persons? Okay, because person is present here also and here. So here actually if we take the height of person, let's say first man has a height of let's say 5.53 feet. The other man have a height of 5.54 feet, and the other man has a height of 5.55 feet. Okay, so what I'm trying to say, that here each of the person will have a distinct height, will have a we can say a difference in height. Okay, here each man has a difference in height from the other. So it is not possible to make all the, we can say, bars. Okay, so here we will use grouping. We can say that here we will draw a bar. Okay, which we can say this bar will represent the persons of height from 5 feet to 5.1 feet. Okay, so we can draw a bar and we can put those persons in this which have a height of 5 feet to 5.1 feet. Similarly, we can say that 5.2, let's say 5.5, let's say 5.5 feet to 5.6 feet. Okay, so if we have a person whose height is 5.52 feet, so it will lie in this category. If a person has a height of 5.54 feet, 5.55 feet, so it will lie in this category, because here you can see 5.5, we can say 56 feet will lie in this category, because here we have 5. Okay, if we remove this 6, so you can see here we have 5.5 to 5.6. okay, so 5.5 is present here, and actually we have 5.56. so you can see that 5.56 will lie between 5.5 and 5.6, so it will lie also in this category. Here I hope you are understanding it, because here we actually we have to draw, we can say we have to make a group here to show the persons. Okay, otherwise it is very difficult. Okay, and now we can say mass of birds. Like this, here is the similar case. Actually here the mass will vary from bird to bird. Here it means that almost we can say, let's say that here we have 2 birds which have equal weights, but actually they have not equal weights, because here we have a problem with our measuring instrument. Okay, why does this mean? This means that if we go deep, so there will be a difference, although the difference is small, but here will be a difference in the masses of the birds. Okay, here will be a difference in the masses of the birds. It means that here all the birds have different masses. So here we will make grouping of it, or we can say here, if we make our first group, so 100 grams to 101 grams. Okay, it means that here if a bird have a mass of 100.5 gram, so it will lie in this category. If a bird has a mass of 5.28, let's say 28 grams, it will lie in this category. Okay, so that's why we use this grouped data here. Now our second question is, write the examples of qualitative and quantitative data. You know that what is a qualitative data? Qualitative data is the data in which numbers are not present, and we can say the quality of the data is present. And it is also known as categorical data. Okay, so let's see, you will be cleared from here. Here we have qualitative data, it means the quality, it means categorical data. And here we have quantitative data, it means here we have the quantity of anything, we can say the quantity of height, quantity of we can say persons, anything. Okay, and it is also known as numerical data. Here we have quantitative data. It means here we have to write any type of data in which numbers are present. Okay, so I can write here number of light bulbs, okay, present per room. Okay, it means here if we take a survey that how many of the light bulbs are present in each room, so here we will get a number, so it will be a quantitative number. Okay, if we take another example of it, so let's see, people used to sleep 6 to 8 hours per day. Okay, or we can say in a day. Okay, so here we have people used to sleep 6 to 8 hours in a day. So here we will get a number of people, okay, who will sleep 6 to 8 hours in a day. It means here we will get a quantity. We can say how many of the people we have here. So it is a quantitative, or we can say numerical data. Now here we have the qualitative, or we can say categorical data. Here we have the quality. Here we have, we can say the type of thing we have. It means that here I can write the color of cars. Okay, color of cars. Let's take the example here. Let's say if my car color is blue, if my car color is red, if it is black, if it is white. So here you can see that we are not getting the numbers. Here we are getting what? Red, blue, white, green, purple, etc. Okay, so here we are not getting the numbers. Here we are getting the quality of the data, that it is of the red, okay, color. It is, here we have blue color, here we have orange color, let's say, So actually here we have the quality of the data, so it is called a qualitative or categorical data. Clear? So in this we will not get a number. Let's take another example of it. Okay, perfume brand liked by people, or we can say name of a perfume, names of the perfume brands liked. Okay, names of the perfume brands. Okay, here we will ask the people who like different brands. Okay, let's say if a person is liking a brand of we can say FAW. Okay, here if a person is liking a brand of mirror. Okay, so here we will get the name. Okay, here we will get the name of it. Clear? So here we will not get the category that this number, this number, or this number. Here we will get a name, a quality. Okay, so here we will get, let's say Mir is a brand. Okay, so we can say that here it is a qualitative data. Clear? So that we have a difference between qualitative and quantitative data, and we have seen some examples. Now our next question is discrete or continuous data. Actually in this we have to tell that whether these two types of data are discrete or continuous. Okay, discrete or continuous. So let's see. Here we have the number of water bottles drunk in a day. Number of water bottles drunk in a day. So here you can see here I will get a discrete number. Actually it is similar to the ungrouped and grouped data, because discrete means a ungrouped data and continuous means a grouped data. So here I have to tell that in this we will get a discrete data or a group data. Okay, here I will get a ungrouped data or group data. So here if I say that here I have drunk 5 bottles in a day, and we can say 6 bottles in a day, 7 bottles in a day, 4 bottles in a day. So you can see I will get a discrete number here. I will get a discrete data 6, 7, 8, 9. Okay, so it is a discrete data. Okay, and here you have to mention that the number of bottles completely finished. Okay, you can also say it this one like that, that number of bottles finished, okay, in each day, number of water bottles finished in each day. Now we have the weight of students in a class. So here if we have the weight of students in the class, just I have told you here that here each person will have a distinct weight, or we can say here each person will have a different weight, although the difference is very small from the other, but there is a different present. So we can say that here it is a continuous data, because here we will take the we can say here we will take a group of data, or we can say that here the students have a weight from 25 kg to 26 kg. Okay, 27 kg to 28 kg. So here we have a continuous data. Clear? Now we have our next question. Here question is which type of graph we will use here. Okay, Here we can say some types of data, and which graph we can use to represent this type of data. We have studied different types of graphs. These are bar charts, okay, or we can say bar graphs, histogram, pie chart, line graph, etc. Okay, so let's see the favorite food of 14 men. Okay, the favorite food of 14 men. Okay, if you draw here in this, if you draw a pie chart, okay, if you draw a pie chart here, so you can actually compare the different types of food, and you can compare that which one is favorite among different foods. Okay, so here you want to compare actually, because you have to find the favorite food. Okay, so here actually you want to compare the things, compare the different foods. So if we want to compare things, so we will use a pie chart, because here we can easily get a know-how that here which is the largest sector we have. Okay, and the largest sector means that this is the favorite food among the people. Clear? So if we do some comparing, so we can use a pie chart. Now in our part B, the product that was sold per month in a year. Okay, the product that were sold here, products, okay, the products that were sold per month in a year. Okay, it means that we have to see, we can say we have this chart in a year. Okay, we have to draw a chart for a year, and we have to see, actually see the products that were sold in each month. Okay, actually here what we are going to do, actually in this graph you can see here we are going to see the change. Okay, we will see that here in this month how many of the products were sold, and in this month what is the change here in the products which were sold, and here in the next month here how many products are sold, or we can say what is the change in the selling of the products. So here actually if we want to see the change here, if we want to see the change, okay, so what we will use a line graph. Okay, we will use a line graph to see the change, because here in the first month we have just like this one. Okay, in the first month we have this selection, okay, this selling, and in our second month we have this selling, in our third month our selling is the most, you can see. Okay, so that's how we can draw a line graph. Okay, clear? So that's how we can draw a line graph to see the change. Clear? Now here actually we are seeing the change of it. Okay, clear? In our third part, people who used to order tea or coffee. Okay, here in this actually we have to see the people. Okay, we have to see the number of people who used to order coffee or tea. So actually here we are using the frequency, or we can say the number of people. So here the case like this one, here we will use a bar graph. Okay, so that we can get a distinct data. Okay, actually bar graphs are used to represent distinct data, and here if we can say if we are finding the frequency, okay, and if we are finding the number of the distinct terms, okay, if we are finding the frequency, like we can say, or we can say number of people, and we have our distinct categories. Here we have coffee, here we have tea, so we will use a bar graph in that case. Clear? Okay, so we will use a bar graph if we have distinct data. Now last one here, the reason for coming school late. Okay, the reason for coming school late. Here you can see that here we have some reasoning, okay, for the students, by the students who come to school late. So you can we can say you can draw a bar chart, okay, your bars should have a same thickness, okay. So here if we use a bar chart here, so we can get a clear data, we can say a visualization here. We can say that here these are the number of students, okay, who come to school late by this specific reason, okay, and these are the number of students we have here which come late to school by this reason, okay. So here we can use a bar chart. Clear? So we have seen some topics here and selection of data and graph, okay. We have learned here how to select the type of data, it means that which type of data we have, and here how to select the graph, that which graph we will use here to represent a data. Clear? So that's it for this video.
Access the entire Mathematics Demystified course at learneasy.us.